Welcome to Fun Facts Daily, your source for just the good stuff. Monday through Friday, we're bringing fun facts and news you can use, all carefully curated to uplift and inform. So give yourself a break, relax, and learn something awesome in just a few minutes every day. Hi everyone, I'm Kyle Wood, and today we're going to be learning all about X-rays. But before we get into the facts, let's warm up our brains with a little challenge to see if you can tell fact from fiction. Consider this. When you have X-rays done in the dentist's office or in the hospital, the technician puts a heavy lead apron over your body to protect your organs from radiation. Since we're normally told to be very careful about lead exposure, many people assume there must not be any other options to protect you from X-ray radiation. What do you think? Is there something special about lead that makes it the only material that can protect us from X-ray radiation? We'll find out at the end of the episode. Now for your word of the day. Our word for today is radiography. That's R-A-D-I-O-G-R-A-P-H-Y. Radiography is the process of producing an image on a sensitive plate or film by passing short wavelength radiation like X-rays or gamma rays through an object. Medical professionals use radiography to view the internal structures of the human body without invasive surgical procedures. Industrial engineers also use radiography. They rely on it to inspect manufactured components for internal flaws, like microscopic cracks in an airplane turbine blade. The resulting images give experts clear visual data based on how different materials absorb radiation or allow it to pass through them. The word radiography combines Latin and Greek roots. The prefix radio originates from the Latin word radius, which translates to a ray or beam of light. The suffix graphy comes from the Latin word graphene, meaning to write or draw. So radiography is literally writing with rays or drawing with radiation. Time for your daily high five, our top 5 fun facts about X-rays. Number 1. The German physicist Wilhelm Röntgen discovered X-rays by accident while experimenting with cathode ray tubes. In November of 1895, Röntgen was using a Crookes tube in a dark lab. A Crookes tube was an experimental vacuum tube used for studying electrical discharges in gases. It got its name from its inventor, Crookes, who came up with it in the 19th century. Anyways, he put thick black cardboard around the gas tube to prevent light from escaping. And despite this physical barrier, he noticed a nearby screen coated in barium platinocyanide began to glow. He realized the tube had to be emitting some sort of invisible energy that was traveling through the air and even going through the cardboard. He named this energy X-rays because in math, X is typically used to represent an unknown variable. Röntgen spent the next several weeks testing the properties of these new rays. He placed objects of various thicknesses, including books and aluminum plates, between the tube and photographic plates to measure the absorption rates. In one test, he put his wife Bertha's hand in the path of the rays for about 15 minutes. The resulting image showed her skeletal structure and her wedding ring, marking the first medical X-ray in human history. After seeing her bones on the plate, Bertha reportedly exclaimed, quote, "I've seen my death," which seems like a perfect sort of ironic statement given the way X-rays would be used to help doctors treat patients more effectively. Although her hand being exposed to X-ray radiation for a full 15 minutes really couldn't have been good for her. Number 2. X-rays are a part of the same spectrum as the rainbow, but their shorter wavelengths make them invisible to us. The electromagnetic spectrum covers all types of radiation organized by wavelength and frequency. All the light we can see, commonly referred to as the rainbow or the visible light spectrum, has wavelengths measuring between 400 and 700 nanometers. X-rays come in between ultraviolet light and gamma rays, with wavelengths ranging from 0.01 to 10 nanometers. This means X-ray photons have a lot more energy than visible light photons. This high energy level allows the waves to pass through solid matter that would reflect or absorb standard visible light. The X-ray's ability to penetrate a material depends on the energy of the photon and the density of the material. Elements with higher atomic numbers have more electrons, which makes it more likely that material will absorb any incoming X-ray photons. Our bones are primarily made of calcium, which has an atomic number of 20, making it dense enough to stop many X-rays. Soft tissue, on the other hand, like muscle and fat, it's mostly made of water and carbon, which have much lower atomic numbers. X-rays pass through soft tissues easily, striking the detector behind the patient, but the X-rays can't pass through the bone so well. So a radiograph is basically creating an image by recording where the X-rays passed through and where they were blocked. Number 3. Astronomers launched specialized X-ray telescopes into space to observe the hottest and most violent phenomena in the universe. Things like black holes, neutron stars, and supernova remnants generate heat in the millions of degrees Celsius. At these temperatures, they stop emitting visible light and instead radiate energy in the X-ray spectrum. Earth's atmosphere acts as a sort of shield absorbing most of the incoming X-ray radiation before it reaches the surface. Because our atmosphere is absorbing the X-rays, ground-based telescopes can't detect black holes or neutron stars. That's why scientists put X-ray telescopes in orbit. In 1999, NASA launched the Chandra X-ray Observatory. It's our main tool for this type of astronomy. Chandra has a set of nested barrel-shaped mirrors to gently reflect incoming X-ray photons toward a detector. These mirrors have to be incredibly smooth, like at an atomic level, because the wavelengths of X-rays are so tiny, even the slightest bit of roughness on the surface would scatter and diffuse the waves instead of channeling them as needed to the telescope. While the materials require microscopic levels of precision, the X-ray Observatory is giving us insights into some of the biggest things in the universe. Data from Chandra has allowed physicists to map dark matter distributions across galaxies. The observatory also captured the first X-ray emissions from the supermassive black hole at the center of the Milky Way. Number 4. During the mid-20th century, shoe stores routinely used X-ray machines to measure customers' feet for proper shoe sizing. In the 1920s, retailers introduced shoe-fitting fluoroscopes. The machines had a wooden cabinet with an opening at the base where customers could place their feet. Customers, salespeople, and parents looked through a viewing port at the top of the cabinet to see the live, glowing X-ray image of the foot bones inside the shoe outline. The idea was this would ensure a perfect fit, and it was especially appealing to parents trying to buy shoes for growing children. By the early 1950s, there were about 10,000 fluoroscopes in shoe stores across the U.S. The popularity of the fluoroscope quickly declined, though, as the scientific community gained a clearer understanding of radiation risks. The unshielded machines exposed users and especially store clerks to a lot of radiation. A single 20-second viewing session could deliver a radiation dose of up to 116 rems to the child's feet, far exceeding modern safety limits. If you're wondering, the current guidelines say people should try to limit their exposure to no more than 0.1 rems per year across their entire body. So people checking their kid's foot in a fluoroscope could be exposing them to about 1,000 times the recommended limit. As you might imagine, state governments began banning the devices in the late 1950s due to the risk of tissue damage and disrupting bone growth. By 1970, regulatory agencies had removed almost all the shoe-fitting X-ray machines from commercial operation. And our fifth and final fun fact for today: art conservators have used X-rays to reveal hidden sketches and earlier paintings under the surface of famous artworks. Before the invention of modern synthetic pigments, artists often mixed their own paints, which could include some heavy metals. Think of colors like lead white, vermilion, a red orange, which was made with mercury, and Naples yellow, which had lead and antimony. These kinds of recipes with heavy metals were common for centuries, so when X-rays pass through a painting, the heavy metal pigments will absorb the radiation. This allows historians to see the artist's initial charcoal sketches without damaging the surface. It also exposes the wood grain of the panel or the weave of the canvas beneath the paint layers. But what's most interesting is the process frequently reveals that artists reused their panel or canvas and painted entirely new compositions over older, discarded works. For example, X-ray analysis of Pablo Picasso's Old Guitarist revealed a hidden portrait of a woman underneath the final composition. Vincent van Gogh frequently reused canvases to save money, and X-rays have uncovered several hidden portraits beneath his landscape paintings. Curators use this layered visual data to authenticate works, determine the chronological order of an artist's output, and study their stylistic evolution. This non-destructive testing also gives us a glimpse into the artist's decision-making process from the initial sketch to the final brushstrokes. Now for some news you can use. If you need to get an X-ray, you can streamline the diagnostic process by wearing something like athletic clothing without any metal components. Clothes with metal zippers, brass buttons, underwires, or snaps can block X-ray photons from passing through your body to the digital sensor behind you. When these metallic items are in the imaging field, they register as solid white shapes known as artifacts on the final radiograph. These artifacts cover the bones and soft tissue underneath, potentially hiding the exact fractures or anomalies that a physician is trying to evaluate. By removing jewelry and wearing metal-free garments, you may be able to eliminate the need to change into the dreaded hospital gown, but more importantly, you'll get more clear results and prevent the technician from having to administer a second radiation dose to retake the scan. Finally, the moment you've been waiting for. At the beginning of the episode, I asked, is lead the only material capable of blocking X-ray radiation? And this one's a fallacy. While lead is the standard material used in medical shielding, it doesn't have any exclusive X-ray blocking properties. The ability of material to stop X-rays depends primarily on its density or thickness, not its specific elemental identity. Lead is just a practical choice for medical facilities because its high density allows a thin, flexible layer to absorb radiation. You could achieve the same level of radiation protection using other materials like concrete, steel, packed dirt, or water, but you would need a concrete wall several inches thick or a layer of water several feet deep to match the stopping power of just a millimeter thick sheet of lead. Lead wins out on convenience and cost, but basic physics tells us that any dense material can block X-rays if we have it in sufficient quantities. And if you're wondering why medical facilities are using lead, a material known for its toxicity along with other heavy metals, it's because lead poisoning requires ingestion or inhalation. It's only harmful if you take it into your body. Medical manufacturers seal the solid lead inside a heavy vinyl or rubber coating, preventing any particles from touching the patient's skin or entering their system. Now, I hope you enjoyed learning a bit about X-rays with me today, and be sure to tune in every weekday for even more fun facts. Fun Facts Daily is an Airwave Media podcast. It was written, recorded, mixed, and edited by me, Kyle Wood. Thanks for sharing a part of your day with me. Be sure to follow Fun Facts Daily on your favorite podcast app so you can keep the good stuff coming your way every day. And if you like the show, please do me a favor and leave a kind rating, review, or just tell your friends about it.